In 1963, scientists studying the Hubbard Brook experimental forest in New Hampshire make a shocking discovery. Their most recent rain samples were nearly 100 times more acidic than usual.
At these levels, additional downpour of acid rain would destroy the region's marine and arboreal ecosystem in a matter of decades. Originally, sharing their findings with fellow researchers, and they wonder if there was any way to prevent it.
To answer these questions, I would first like to share with you some insights about acid rain, one of the most significant yet often overlooked environmental issues caused by human activity. First, let's explore the definitions of acid rain.
Acid rain refers to any forms of precipitation, rain, snow, fog, or even dust that contains unusual high levels of acidic components, mainly sulfuric acid and nitric acid. Normally, rainwater has a pH of around 5.6, but in pollution regions, it can drop to below 4.0, making it several times more acidic. This phenomenon occurs when the sulfur dioxide and nitrogen oxides crack with water vapor and oxygen in the atmosphere under the influence of sunlight and catalysts like ozone and hydroxide radicals. The resulting acids then fall back to the Earth's surface through rain or dry deposition. So, where does the acid rain actually come from?
Historically, acid rain isn't entirely new. Natural events, such as volcano eruptions and wildfires, have long released acidic gases into the air. However, the problem became much more severe during the Industrial Revolution in the 18th and 19th centuries, when coal-powered factories and massive industrial expansion emitted huge amounts of pollutants. The term acid rain was first coined in 1852 by the British chemist Robert Angus Smith, who studied the effects of industrial pollution on rainfall in Manchester. Since then, acid rain has become a global environmental concern, particularly in Europe, North America, and East Asia. So, what is the exact cause of acid rain?
First, the burning of fossil fuels such as coal and oil releases sulfur dioxide and nitrogen oxides into the atmosphere. These pollutants combine with water vapor and oxygen in the air to form sulfuric acid and nitric acid, the main component of acid rain. In addition, coal-fired power plants are massive sources of sulfur dioxide emissions. When coal is burned to generate electricity, it releases large amounts of sulfur, significantly contributing to acid rain. Moreover, transportation and industrial factories also play a substantial role by emitting nitrogen oxides. Even natural phenomena such as forest fires and volcanic eruption contribute to the problem, though to a lesser extent. Furthermore, agriculture also contributes to acid rain, because when fertilizer containing high amounts of nitrogen compounds are used, these substances can volatilize or be washed into the air as nitrogen oxides.
The consequences of acid rain are far-reaching. Acidifies soil, washing away essential minerals like calcium and magnesium, and weakens plant roots, making forests more vulnerable to disease and harsh weather. It also lowers the pH of lakes and rivers, killing fish, amphibians, and microorganisms. Some lakes in Scandinavia and Canada become known as dead lakes because life could no longer survive there. Furthermore, acid rain corrodes buildings and cultural monuments, especially those made of marbles and limestone, such as the Parthenon in Greece or the Taj Mahal in India, whose surfaces have been visibly damaged by acidic pollution. Although acid rain itself does not burn the human skin, toxic gases responsible for it can cause respiratory illnesses including asthma and bronchitis. Now, let's take a look at some interesting facts about acid rain that many people may not know.
For example, pollution doesn't necessarily affect the area where it's produced. A current can carry sulfur and nitrogen compounds hundreds or even thousands of kilometers away, meaning one country's emissions can damage ecosystem in another, a phenomenon known as transportatory pollution. Additionally, areas with limestone or chalky soil are more resistant to acid rain because such mineral neutralize acids naturally, while regions with granite or sandy soil experience much great harm. Another interesting aspect is that even in dry weather, acidic particles can settle on surfaces, process called dry deposition, and are later washed into ecosystem when it rains, and intensifying the damage. Returning to the scientist's question, is there any way to stop it?
To combat acid rain, many nations have implemented stricter environmental policies. The use of clean energy sources like wind, solar, and hydropower has significantly reduced emissions. Factories now install flue gas desulfurization system, commonly known as scrubbers, to remove sulfur dioxide before it reaches the air. International cooperations have also played a key role. For example, the 1979 Geneva Convention on Long-Range Transboundary Air Pollution marked one of the first global efforts to tackle acid rain.
Overall, acid rain serves as a powerful reminder of consequences of industrialization and environmental neglect. It illustrates how invisible chemical reactions in the air can reshape entire ecosystem on the ground.
By reducing emissions, switching to cleaner energy, and maintaining the international collaboration, we can ensure that future generations will experience rain as a symbol of renewal, not destruction.